Hello friends, welcome to Engineering Pandu. In this video we discuss about introduction to aero engines and material requirements. Friends, here is the general layout for aero engine, and here you can see there is a compression, then there is a combustion chamber, and there is a shaft in the center, and this is the turbine in the middle, and there will be a exhaust nozzle. So the air is coming from here, and the exhaust is from this side. Friends, if you are not subscribed to Engineering Pandu, please subscribe to Engineering Pandu. We will keep on uploading few good investment related videos where you can learn few more things and invest in your general knowledge. Friends, this is the general image of Rolls-Royce Trent 800 engine. Then we have, now let's go to the different parts. Then we have disc, and this disc is subject to centrifugal loads and biaxial tensile stresses, radial and tangential, and stresses increases with the square of rotational speed. Friends, here the thermal stress is also present, and the temperature gradient between the inner and outer section of the disc is different one. Then we have shaft where it is subject to torsional loads as well as bending loads as well as tensile loads. This is the image of shaft. Then we have combustion chamber where we have pressure generating tensile stresses, whereas thermal stresses are also present. And if we talk of engine materials, then here you can see the general layout, and then there is a color coding for different type of materials used. Here titanium is used, whereas in this red portion nickel is used, whereas here with the orange color steel is used. Friends, then this yellow one is with aluminium, and then there are composite at the green location. Friends, now discuss about the compressor disc and its operating condition. The compression discs are among the most critical parts components of the aero engines. The primary function of the compressor disc is to provide fixturing for the compressor blades located in the airstream. So the compressor discs are used to fix the compressor blades, and it will provide a kind of fixturing for the blade, and it must withstand the load of the fan blades, normal running and planned blade off. Then it must withstand the impact load of a fan blades during the burst strike, etc. And the material required for such conditions are the properties required, might be alloy, can be is summarized as follows. It requires a high lead stress and tensile strength to ensure accurate blade location and resistance to over speed burst failure. It also requires ductility and fracture toughness to impart tolerance to defects, high low cycle fatigue strength and resistance to crack propagation to prevent crack initiation and subsequent growth during repeated engine cycling, and high stiffness and low weight. Low weight is the basic criteria for all the material. Then compressor disc material, the compressor discs are mostly made of titanium alloys. Some nickel alloys are also used in HPC discs. These are generally manufactured using wrought root. Then material being used is titanium alloys, and then nickel based super alloys. Friends, now the compressor blade. Now the compressor blade operating condition is such that the radial load on each fan blade can reach up to 90 tons at takeoff time. So at takeoff time the maximum load is generated, and then each blade must withstand 20 tons of bird impact load. And stresses from the three main sources are centrifugal loads, tensile, then aerodynamic load, bending, and thermal stresses. It is not a major player for fans but a significant for turbines. Then compressor blade materials for vanes and blades, titanium alloys and some high strength steels and nickel alloys are used mostly in HPCs. The material used in the blades is titanium alloy or nickel based alloys, whereas titanium alloys and steel and nickel based super alloys. Friends, here some of the materials are mentioned. Then we have compressor material where titanium alloys are used. Operating temperature up to about 600 degrees centigrade. It is good in strength to weight ratio, good fracture toughness and fatigue resistance, oxidation resistance. Blades and discs are usually forged, whereas large blades are made of super plastic forming and diffusion bonding techniques. Then titanium alloys are basically used for fan disc blades and compressor disc. Typical alloys might be TI6 AI4V, then IMI 834, which is used in the application up to 630 degrees centigrade, almost twice the capability of routine titanium alloy. Then the major performance improvements are now being made by either using titanium intermetallic material or titanium metal matrix composite material. Then gamma titanium aluminides are also most advanced of the intermetallics with the half of the density of the current titanium alloy. Alternatives to titanium are primary steel and nickel alloys with subsequent or consequent mass increases. Then we have shaft material. Here steels are used. Operating temperature up to about 800 degrees centigrade is required. Good strength to weight ratio is required. Good strength to volume and good fatigue resistance, and it is forged one. The material are steels, CMV, super CMV, Hicro, and nickel based super alloys IN 718. Then combustion chamber materials, the material used present are generally wrought nickel based super alloys. Nickel alloys operating temperature up to about 1100 degrees centigrade and good thermomechanical fatigue creep and oxidation resistance formable to fairly complex shapes. And then materials being used are nickel based alloy super alloys C263, mnemonic 86. Then turbine blade material requirements, as we have discussed, creep resistance is the basic requirement. Then thermal fatigue resistance, oxidation corrosion resistance, toughness, microstructural stability, then coating capability, low density and low cost. These are the basic primary requirements and the materials to meet the operating temperature and component stress level demanded. So nickel based super alloys are mostly used. Some high strength steels are also used in LPT disc. These are generally manufactured using rod. Then material being used are nickel based super alloys U720 Li or Waspla alloy, and then Inco 718 and 901. And high strength steel is also used M152 and FE535. So friends, material used in aerospace, here is the normal summary. For fan blades, superplastically formed titanium alloy skin diffusion bonded to a titanium honeycomb core. Then for compressor vanes, disc and blades with increasing temperature, the material change from titanium alloy to 12% chromium steel to nickel based super alloys. Then for combustor, high temperature nickel based super alloys are used. Then for turbine blade, disc and vanes, high temperature nickel based super alloys are used. For shafts are made of steel, and casing is made of aluminum alloy and composite to reduce the weight. So friends, these are the general introduction to the aero engine material requirements, and basically all materials are basically selected with basic criteria of low weight and fatigue resistance and thermal resistance. So friends, I hope you will like this video. Thank you very much and happy learning.